SICK AG, one of the world's leading manufacturers of sensors and sensor systems for factory and process automation. Most of the sensors are produced at the original facility in Waldkirch. Following quality control, they are packed and orders are made up for further transport. The transport system used for internal goods transport is equipped with an S300 safety laser scanner that detects persons on the route in good time, stops the vehicle and thus prevents collisions. SICK's logistics centre is here that on a warehousing area of around 4,500 square metres, more than 31,000 SKUs are stored before being packed to orders. In addition, there are over 15,000 SKUs earmarked for in-house production. The pallets are labelled with HF transponders before storage. The pallet can then be automatically detected and controlled during processes. The use of radio technology increases reliability because dirt and mechanical stress do not affect readability of the transponder. Simple. The C4000 safety light curtain differentiates between man and material without any other additional sensor. A photoelectric reflex switch recognizes the tote to be stored and starts the rollers. The totes are guided fully automatically through the 400-meter-long conveyor system. Barcode scanners, activated by photoelectric proximity switches, identify the totes, thus allowing conveyor sections, switches and transfer points to be controlled. Proximity switches with logic functions are used in the accumulation conveyor to ensure that totes are channeled in faultlessly. Protected between the rollers, they recognize the totes and stop and start them, thus preventing them from colliding while in transit. Incremental encoders monitor the speed of the rollers and thus also the speed the totes are conveyed at. At various points on their way through the logistics centre, the totes are identified by barcode readers. Automatic destination control ensures reliable flow and fast availability of the SKUs, either for storage in the high bay warehouse or for making up orders and preparing them for shipping. Photoelectric barriers activate the switches in the conveyor system. In the 8-meter high small parts store with 42,000 tote compartments, stackers store and retrieve the totes. SICK DME series laser distance measuring devices inform the stacker control unit of its current position within milliseconds. The reflector at the end of the warehouse aisle ensures that the laser measuring beam is reflected well, thus enabling highly accurate positioning of the stacker. Communication with the control system is via optical data transmission. ISD series devices can transmit data wirelessly and interference-free over distances up to 200 meters. The systematic use of field buses, for example ASI, keeps the need for wiring in the logistics center to a minimum. The motor feedback systems, incorporated in the drives, are used for closed-loop motor control and positioning. Inductive sensors position the lifter table. Absolute multi-turn encoders allow accurate positioning of the telescopic table flush with the shelves. As a result, any tote can easily be stored in or removed from the compartment assigned to it. Before the totes are stored, DS60 series distance sensors ensure that the rear compartment really is vacant. The advance of the stacker's telescopic fork is controlled and monitored by absolute multi-turn encoders. Inductive proximity initiators register the various lifting positions of the centering unit. Through-beam photoelectric switches monitor positioning on the telescopic table, thus ensuring that no tote protrudes when the stacker moves through the aisle. Collision-free tote transport in picking, as well thanks to SICK's special WTR series accumulation roller proximity switches. Safe. Hand protection with the C2000 safety light curtain, preventing accidents and lawsuits. Inductive sensors detect the correct position of the trays. In the dispatch department, shipping orders are identified wirelessly and ergonomically with cordless handheld scanners. Light barriers in the strapper recognize the length and position of the cartons, so the cartons are thus always strapped in the right place. Persons or vehicles approaching the gates are detected by an S300 safety laser scanner, and they are reliably opened in good time. The containers are labelled with RFID transponders to increase transparency. This allows all containers to be automatically detected in intralogistical processes. Thus, more than 400 sensors ensure that in the logistics centre, more than 1,700 shipping orders can be processed. You will also find SICK laser scanners in the security sector. The outdoor LMS 221 monitors the front of the building. SICK's Logistics Technology Centre. SICK offers customers an area of more than 500 square metres support and service at the test and training centre. An omnidirectional barcode reading system ensures that the barcodes on the objects are reliably read in any orientation. For this purpose, an application-specific number of laser scanners are used in an appropriate arrangement. RFID used for track and trace applications increases transparency in logistical processes and can contribute to increased reliability in, for example, airports. The IVP ruler camera system also permits the side-by-side detection of small objects during operation. Tailor-made. The M4000 multi-beam safety light switch prevents accidents. The sensor is quickly adjusted with onboard configuration. Accurate volume determination. This is state-of-the-art sensor intelligence. Numerous individual values are determined and evaluated at lightning speed with light time-of-flight technology. Both rectangular and irregular objects can be measured. In combination with dynamic scales and a reading station, all relevant data on a package can be detected in one location. Moreover, all VMS units and scales can be approved for trade according to MID and OIML, so that their use also pays financially. Using 6 cameras, this ICR 890 camera tunnel detects 1D and 2D barcodes on all 6 sides of an object in any orientation. In addition, high-resolution images of all 6 sides are captured and used for automatic address label identification or general image archiving by the downstream OCR systems. This ALIS system is used for the automatic identification of flight baggage. The system is designed and configured in such a way that the barcode label attached to handles on the luggage is detected in any orientation. SICK. Logistics solutions for greater efficiency.